Have you ever found yourself in a situation where you need to scale a quantity or even an object to create a product that stays proportional? In such a case, we're looking at using ratios, and today's lesson will teach you the math that will prevent your recipes from turning into an unscaled disaster. This is Mastering CSEC Mathematics Bite Size. Whether you're drawing building plans, understanding how to use a map in geography, or just simply trying to manipulate that family passed down sponge cake recipe, you require a little knowledge about ratios. A ratio is a multi-part numerical statement which shows the relationship among a group of quantities. Each part of the ratio corresponds to one quantity. On your maps, this can look like a scale of 1 to 250,000. And to keep your recipes proportional, this can look like 1 to 2 to 3 for water to flour to eggs. The double dot, which we know as a colon, is used to separate the parts of the ratio. Let's see how ratios work in these scenarios. Nikki is baking cakes for her school's cake sale. Her mom's recipe, which has been passed down like a generational heirloom, produces some of the best sponge cakes, and she knows it's sure to be a hit. Nikki has one tiny problem. How much ingredients would she need for 12 identical cakes? Mom's recipe card says the main ingredients for one cake are 2 cups of flour to 1 cup of water and 3 eggs. In order to keep the quantities in proportion for the large quantity of cakes, she must multiply the quantities of each respective ingredient by 12. Do you recall your 12 times tables? Because that's sure to help you solve this simple math problem. This means she'll need 24 cups of flour, 12 cups of water, and 36 eggs. When Nikki takes a quick look at the items she has at home, she realizes that she will not have enough ingredients to make 12 cakes. Looks like she is going to need to take a trip to the local shop to get additional ingredients. While using maps may sound archaic, once upon a time, it was a means of accurately navigating areas. Scales on maps are used to represent the large distances. In reality, on a small scale representation of the location. Now imagine being a backpacker trekking through unknown territory and only having to rely on a map. Do you think you'd be able to accurately read and interpret the distances, or would you end up getting lost? Even if you were to look at a digital map of an area, you'd still see scales displayed, which are basically a ratio of the same quantities. Without ratios, your navigation apps would not be accurate, and you'd probably end up taking a wrong turn and get lost in the middle of nowhere. And speaking of nowhere, if you're looking for an activity to keep you occupied in your solitude, the Mechaduck is your local online shop for hobby kits perfect for passing the time. They also do free delivery to absolutely anywhere, so don't worry your head off about what to do. The Mechaduck has Gunpla, figurines, and model cars too. Let's take one last look at ratios as it applies to real life. Jason wants to host a cooler fete at the beach at the end of August. However, to get the approval for the event, he must submit documentation to the relevant authorities concerning details of his event. One such detail, the quantity of persons he anticipates will be in attendance. Jason's friends tell him that he'll get a huge turnout if he ensures that the number of women at the party is larger than the number of men, but he can't have too many women either. After some careful consideration and observing other events, he decides it may be best to go with a ratio of 2 men to 3 women. He decides a total of 400 persons should be anticipated as attendees. Jason then uses this to determine the least number of tickets he should print. Jason's advertising campaign encouraged persons to purchase tickets in groups to ensure that the sales maintained his desired ratio by advertising group specials of 10 tickets, 4 males and 6 females. Jason sold 120 male tickets. How many persons can Jason expect in attendance at the event? To determine the total attendance, we first divide 120 by 2. A nice shortcut here for mentally dividing this number. Divide the non-zero digits in 120 by 2. 12 divided by 2 is 6. Next, add a 0 at the end of this number and we get 60. That tells us the factor to multiply the female part of the ratio by. Using this factor, 3 by 60 will tell us the number of female tickets sold. Recall that trick for multiplying by multiples of 10 from our last bite-sized lesson? Find the product of the non-zero digits, 3 by 6. This gives us 18. now add a 0 at the end of it, and this gives us 180. We know the total number of male and female tickets sold, so now we add these two numbers together to determine the total number of persons we can expect at the event. 120 plus 180 leaves us with a total of 300. Jason's event seems to be promising for quite a significant turnout already. If you found this lesson informative and it helped you understand how to work with ratios, be sure to like and share with your friends. And don't forget to follow us for future bite-sized lessons.